Come join us.
She has got exams, so she told that she has to study. So that's why we'll put this recorded lecture.
Okay, cool.
Yeah. Sure. Alternating current. What is meaning of alternating current? The current which changes its sign after every half cycle is called alternating current.
Yes.
What is meaning of alternating current?
I also had doubts with this chapter's cancellations.
This few parts are cancelled at the end. LC oscillation is cancelled. Choke coil is cancelled.
There is more.
Other is I will tell you bandwidth is cancelled. Q factor is cancelled. So that will come at the end. The current which changes its sign after every half cycle is called as alternating current. It is given by I equals to I naught sine omega t, where I naught is called as maximum current. Very simple chapter is this one, maths related it is, right?
Done, sir.
Peak current. Sometimes also called as amplitude of current. So the maximum value of alternating current. The maximum value of alternating current is called as peak current. It is given by I naught equals to E naught upon R, which is NAB omega upon R. Maximum EMF of alternating sources NAB omega. So peak EMF or voltage is same. The maximum value of alternating EMF is called as peak EMF. It is given by E naught equals to NAB omega. Right. Done.
Yes, sir.
Mean or average value of alternating current or voltage. First one for one cycle. One cycle's mean is always 0 because whatever is in crest side exactly same is in trough side. So it will be equal opposite. Therefore, for one cycle, average will be always 0. So during one complete cycle, alternating current during one complete cycle, alternating current flows in one direction for half cycle and in opposite direction during the remaining half cycle. Hence, for one complete cycle, mean value of alternating current is 0. Right. Done full?
Yes, sir.
Show that for one complete cycle, average current is 0. Consider alternating current I equals to I0 sine omega t. Average value for one complete cycle, that is t equals to 0 to t equals to t, comma I average equals to I dt for one complete cycle divided by time for one complete cycle. Just copy till this formula, then I'm substituting the values and integrating it. I dt for one cycle divided by dt for one cycle is called as I average for one cycle.
Done, sir.
Okay. So denominator integration of dt will become t, and limit of integrations are lower limit 0, upper is t. I naught is constant. What is integration of sine?
Cos
Plus cos or minus cos?
minus.
So minus cos omega t upon omega from 0 to t. And this is t minus 0. So therefore I naught upon omega t minus cos omega capital T minus of minus cos omega into 0. So it is I naught omega into t minus cos 2 pi by t into t minus minus plus cos 0. So I naught omega into t. What is cos 0? 1. Cos 0 is 1. And cos 360 is also 1. This is minus. So I naught upon omega into t minus 1 plus 1 is 0. So equals to 0. Right. Thus for complete cycle, we are getting average alternating current is 0.
Done, sir.
Okay. Thus, for a complete cycle, the average or mean value of alternating current is 0. 1 minute, I just write down. हेलो, हाँ मदर, मैं तो घर पे हूँ यार, लेक्चर है। मैं काम करता हूँ ना, वो मैं ट्रांसफर कर देता हूँ। मेरे वही, हाँ 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 हाँ, मैं कर दूंगा, ट्रांसफर कर दूंगा ट्रांसफर। एक्चुअली क्या है, वो बेनिफिशियरी बनाना पड़ेगा ना। हाँ हाँ, और मेरा वही बैंक का है, अगर मैं चेक भी दिया तो भी ट्रांसफर एचडीएफसी का। मैं ट्राई करूंगा ट्रांसफर करने के लिए, लेकिन क्या उसके लिए वो पहले बेनिफिशियरी एक बार बनाना पड़ेगा। मैं तो आज शाम तक मैं कैसे भी कर देता हूँ 10-11। हाँ, यस यस, चलो। Thus, for complete cycle, average or mean value of alternating current is 0. Similarly, the average value of alternating voltage for a complete cycle is also 0. Right. Sometimes only in one liner they can ask. This is for complete cycle, or for half cycle it will come different. Sure. Can I clear this now?
Yeah.
Now, mean value of current for half cycle. Mean value for half cycle, comma I average is equals to I dt for 0 to half of time period. Integration of dt for 0 to half of time period. That is I naught sine omega t dt from 0 to t by 2 divided by dt is t from 0 to t by 2. So this will become t by 2 minus 0. This one is I naught minus cos omega t upon omega from 0 to t by 2. Copy this much. Okay, done this much.
Yes, sir.
Simplifying further. Minus, sorry, I naught upon omega, this 2 will come up upon t, minus of cos omega 2 pi by t into upper value t by 2, minus of minus 2 pi by t into 0. So this will become 2 times I naught omega into 2 is 2 pi by omega. T is 2 pi by omega. This will get cancelled, 2 cancel. So we get I naught upon pi. This is T cancel, 2 cancel. Cos of 180 is minus 1. Minus minus plus cos 0 is 1. So this will become 2. So it is 2 times I naught upon pi, which is same as 0.637 I naught. So half cycle mean value is 2 upon pi I naught or 0.637 I naught. Copy till it. Can I clear this again?
Yeah.
Thus, the mean value of alternating current in half cycle equals to 2 upon pi I naught, that is 0.637 I naught or 63.7% of peak value of current. Similarly, for half cycle mean value of voltage equals to 2 upon pi V naught, which is same as 0.637 V naught or 63.7% of V naught.
Done.
root mean square or RMS value of alternating current. Root mean square, also called as RMS value. Root mean square or RMS value of alternating current. The root mean square. That means square root of mean of squares. So root means square or RMS value of alternating current is defined as square root of average of I square mean, I square bar, average of I square, okay, I square during a complete cycle where I is instantaneous value of alternating current. The square root of average of I square during a complete cycle, I is called instantaneous value. Just write this much, then I'm deriving the formula. I square's mean and its square root is called as RMS value. Written?
Yeah.
So we want to find I square's mean and then its square root. This is nothing but I square dt for one cycle divided by time for one cycle. I means I0 sine omega t square dt for one cycle integration of dt is t, 0 to t. So that will become I naught square sine square omega t dt for one cycle upon t minus 0. So I naught square upon t integration of sine square omega t dt from 0 to t. Sine square theta has no formula in integration. You have to convert in power 1. So just copy till this, then I'm doing further. I naught square upon t integral of 1 minus cos of 2 omega t upon cos theta. Sine square theta is 1 minus cos 2 theta upon 2, 0 to t dt. Sine of 4 pi upon 2 omega, this whole thing will become 0. That is I naught square upon 2p I naught square upon 2t into t 0 minus 0. I naught square upon 2t into t. That is I naught square upon 2. So square root of I square mean is equal to square root of I naught square upon 2. That means IRMS is I naught upon root 2.
the answer.
I 0 upon root 2 or 1 upon root 2 means 0.707. Similarly, Vrms equals to V naught upon root 2 equals to 0.707 V naught. Complete till this completed. Done, I think, till last line.
Yes, sir.
Now, what is meaning of phasor and phasors and phasor diagram? See, phasors are nothing but representation of alternating current or alternating voltage in vector. That means the vectors representing alternating current, the vectors representing alternating current or alternating voltage with angle between them called as phasor angle. Is or are called as phasors. So simple में vector representation of this alternating current or voltage with phase angle between them is called are called as phasors. A diagram representing alternating current and alternating voltage as rotating vectors with phase angle between them is called as phasor diagram. So phasors means vector, phase diagram is representation of that vector with angle between them. Now there are three circuit, only resistance, only inductor, only capacitor, then power in them, then resonance circuit. That will complete the chapter. So in 2 lectures, we can complete this chapter full. Then only left out will be electromagnetic waves. Then we'll start with revision. Done, na?
Yeah.
So today we'll stop here because next 3 circuit I want to do on one day so that link will understand.
Okay, no problem.
So next class as usual, and we'll try to complete by next week this chapter.